we present ODHSR, a novel framework for online dense 3D human scene reconstruction. Given a monocular RGB video captured in the wild, ODHSR performs camera tracking, human pose estimation, and dense human scene reconstruction simultaneously. By explicitly modeling the human scene occlusion and utilizing monocular geometric priors holistically, ODHSR faithfully reconstructs the spatial correlation between dynamic human and static scene and achieves superior performance in reconstruction and human pose estimation. Our method is underpinned by 3D Gaussian splatting and a lightweight holistic human scene representation designed for efficient training and rendering. We decompose the avatar deformation into rigid and non-rigid part and propose a time-pose-dependent deformation module that learns the irregular clothes and hair deformation efficiently. This design enables high-fidelity reconstruction, which serves as a critical prior for precise pose tracking. By integrating scene Gaussians by depth order, a holistic human scene representation is achieved, which enables our occlusion-aware human representation. Our framework builds upon the conventional SLAM pipeline. For each incoming frame, we initially perform joint optimization of the camera and human poses by minimizing the frame-to-model residuals, followed by a keyframe selection process. Concurrently, a second thread executes dense mapping and local bundle adjustment within a small, localized keyframe window. Our method incorporates multiple optimization constraints applied jointly to achieve globally coherent tracking and mapping. We leverage off-the-shelf estimators for human silhouette, monocular depth, human key points, and optical flow, calculating their residuals relative to renderings generated from the holistic reconstruction. These residuals are used to iteratively refine the poses and map. Notably, we render occlusion-aware human silhouettes and rescale the monocular depth prior with the reconstructed scene and human jointly, demonstrating significant improvements in accurately modeling the spatial correlation between humans and the scene. Our proposed approach achieves state-of-the-art reconstruction quality on the EMDB dataset, where we faithfully model the details of the human and scene. Despite completely running online without the ground truth camera, our method overperforms the baseline methods in image sharpness and data fidelity. Our online reconstruction framework removes most of the floaters and achieves high clarity in the static scene reconstruction compared with offline baseline methods, which require known cameras or pre-estimated scene points from Colmap. Moreover, our approach accurately estimates camera trajectory in the scale-agnostic monocular setting. While scene-only tracking methods struggle to recover metric scale, our holistic reconstruction and tracking system leverages human priors to overcome this limitation. Even after aligning scale with the ground truth, our predicted trajectory outperforms other contemporary Gaussian-based SLAM methods, highlighting the advantages of holistic modeling over scene-only approaches. Additionally, our method outperforms state-of-the-art pose predictors in global trajectory accuracy, enabled by globally consistent reconstruction. In contrast, end-to-end methods struggle with diverse environments, such as elevation changes and out-of-distribution poses. Finally, we evaluate the impact of our mapping objectives on human subjects. Our proposed constraints enable generalization to novel views and poses, even with limited data. Without them, the reconstructed avatar exhibits uncontrolled Gaussians, particularly in challenging regions like the face and arms. To summarize, our proposed online dense human scene reconstruction framework achieves improved performance in reconstruction quality, camera tracking, and human pose estimation. It marks a significant step forward for real-time, monocular, video-based 3D reconstruction. Thank you for watching. Please refer to our paper for more details.